Hi, in this session I'll be covering review actual query execution plan using dbms explain.displayCursor. This will be the part 2 of the video tutorial for review actual query execution plan using dbms explain.displayCursor. In part 1 we have covered what is execution plan, various methods to view execution plan, some problems of binding with explain plan and auto-res, and I have shown a demo on it, and I have discussed basics of displayCursor function. In part 2, I'll be covering setup and view execution plan using displayCursor, overview on execution plan shown by displayCursor, understand estimated and actual resource execution statistics, IO stats, memory stats, usage of temp. I'll execute some queries and I'll show some demos. Okay. To use this displayCursor function, you need to have select privilege on below dynamic performance views: $SQL plan, $session, and $SQL plan statistics all. Among these, the last one is very much vital, cause from this particular dynamic performance view, $SQL plan statistics all, from this all the extended statistics are displayed by displayCursor function. To use to enable gathering the row source execution statistics, you need to use either gather plan statistics hints, or you need to set the statistics level parameter to all. So now I'll discuss the extended statistic shown by the displayCursor function, and I'll show some demo. So begin with starts. Starts represents number of times the particular step is executed. It will come if you only use gather plan statistics hint or set statistics level to all. Most of the time it will be 1, but you can see while performing nested loop join you might see a higher number. Okay, so let's check that. I'll first set the statistics level to all in my session. It's now all. Then I'll use this query. I have a small table emp, and I will join it with departments, and I am using useNL hint to influence the optimizer to use the nested loops join. Okay, 6, 7, 9 rows are fetched. Let's check the plan. Yeah, here you can see it is showing as 27 starts, and there are two other columns, rows, a rows. We'll first talk about this, then I will explain later on. Rows, this is the estimated number of rows calculated by the optimizer during its parse phase. Okay, and this is same as the rows column of your explain plan output. Okay, and a rows represents the actual number of rows flows out in the each step. Fine. And here in nested loop join, it is basically like two embedded for loops. In outer loop there is the smaller data set, the smaller table, and in inner loop there is the bigger data set, the bigger table. Here in outer loop, if you think like this, there is departments, and for each record of departments all it will loop for employees. Now here in this case for nested loop, this starts into rows should be nearby a rows, nearby or equal to a rows. Okay, so let's check this. Select 27 into 25 from dual. It is 675, which is nearby the actual value of rows, 679. So this is what I wanted to show regarding nested loops join. Okay, so let's go to our next one, actual time, a time. A time represents the actual time spent on this step. It can show wrong info while using gather plan statistics hint. Actual time, the a time should be cumulative. Okay, let's see what happens when we use a nested loops join. Before that I'll set I'll what I wanted to say, let's check what happens when we use the gather plan statistics hint. Okay, before that I'll set my statistics level to typical, the default value. Then I will use this gather plan statistics hint, session altered. I'll execute this query. with gather plan statistics hint. It will join two tables, and this is the basic query. Okay, you can understand what is doing. So let's view plan for this query, and we'll concentrate on the A time. Okay, 73,300 rows selected. Here, if you check the particular A time column, the values it is showing, they are not cumulative. This is the rightmost step. This is the first step in the execution plan. It is showing 3.41, then the next one is 2.03, and these values, if you see from top to bottom, these values are not cumulative, but it should be cumulative value in a execution plan. So this is one problem with the gather plan statistics hint, that it can show discrepancy. It can, in its output, or in display cursor output, while using this particular hint, you can see discrepancy in A time. So let's check what happens if we use the statistics level parameter, and if we set to all. Before that, I will flush the buffer cache and shared pool to bring back my old environment. Okay, it's flushed now. Now I will set the statistics level to all for this session. It's now all. Now I'll execute this same query without that particular hint, gather plan statistics. Okay, I have executed that query. After it is executed, I'll review the actual time shown. Okay, so there will be nearby 73,000 rows. Yeah, 73,300. Yeah, here if you see, these values are now cumulative. Okay, but here one problem you can see in this part. In this happens sometimes. In this part you can see from 2.28 the values have grown up to 4.07. This is because of this particular setting, statistics level to all. If you set to all, it checks the statistics details in very granular level, so it causes bit of overhead. Because of that, it can add some more time. Okay, this was the reason, but this is not very often. But in this case, this actual time is very much consistent, and it's cumulative, which we expected. Okay, let's go to our next slide. IOStats, which is very vital. It will come if you use the gather plan statistics hint, or set the statistics level to all and use IOStats or all stats in your format parameter of display cursor function. It will show two additional columns, reads and buffers. Reads represents the physical reads, and buffer represents the logical reads, or the buffer represents the consistent reads and read in current mode. Okay, in Oracle, blocks may be retrieved in two ways. Okay, it may be a current mode read, or it is known as also db block get and the consistent gets. A current mode get is retrieval of block as it exists right now. Okay, and it will often see this while you are doing any DML operations like insert, update, delete. Okay, and consistent read is the retrieval of blocks from the buffer cache in read consistent mode, and it may include read to the undo segment also. Okay, in case of SQL query, it will perform consistent reads only generally. Okay, so we'll check now one thing. We'll do a demo. Before that, I'll again flush my shared pool and buffer cache. Fine. I'll execute a insert statement, insert into this table. This is test memstats, just to identify my query from $sql. Okay, this is just a comment. Okay, then what I will do, uh, I will do bit of tally between the $sql plan statistics view. In this particular dynamic performance view, you can see these columns last CR buffer gets. Okay, this means the consistent gates of the last execution, last CU buffer gets. This means the current mode reads of the last execution, and last CR buffer gets plus last CU buffer get should be same as our buffer in the display cursor output in the execution plan. Okay, and you will also see last disk reads, which is same as physical reads, and last disk write, which is same as the writes, number of writes, because of this insert statement. It will come when you are doing a insert. Okay, okay, now let's see our what is SQL ID. I'll view it from $sql. This is my SQL ID. Okay, let's view the plan. Here you can see two additional columns, buffers and reads, and another one also writes. Writes will not come if we are doing any select, but we are doing a DML insert. Okay, anyway, let's tally what I was saying. Buffer should be sum of consistent reads and current mode reads at each step. Okay, and read will be same as the physical reads. So let's execute our query. This is our SQL ID. Yeah, here if you see, this is the consistent gets from my query from this $SQL plan statistics view. Okay, now if you start from the rightmost part, table access full EMPL. In this part, the execution plan says that it have done 35363 physical reads and 35375 consistent mode reads, the logical reads. In this part there will be 0 current gates, no current mode read. It is fetching the data, just a SQL query, cause it in our SQL insert statement it is just insert into this, select this from this table. Okay, anyway, so here if you see 375 plus 0 375, these two values are same. In second part, sort order by, here the number of buffer is 35382. Fine, here you can see consistent get 35375 plus 7 equal to 35382. These two values are same. Fine, and here in the last part 335k. Okay, that means 335,000. Here you can see number of consistent read 90,172, and this is the number of current gates. If you sum it, this value will come as we have done in our query in this part. So this is matching exactly, and also the reads value 35363, in there it is 63435, and in last 63561. This is the physical reads. Physical reads may also means the reads from temp also. And this is writes, and writes here you can see 28072. This is amount of writes 28072. It will come because you are doing an insert. Okay, so this was the IOStats part. Now we'll go back to go to memstats. If you use this memstats format parameter or all stats, this displays the memory management statistics regarding the estimated size of the required PGA work areas to do a memory intensive operation like sorting, hash join, bitmap merge, bitmap create actions. Here if you see in our query, we have in our insert statement we have used this sort order by. We have done a huge sort. The data sheet is about for 20 lakh, and we have sorted by these 4 columns. This is the number of rows created. This is the data set. Okay, so let's go back to PPT. Yeah, this it can show 3 columns: omem, one mem, used mem. Okay, you can also see another one, used temp. So we'll discuss about all of this now: omem, one mem, used mem, and used temp. Omem represent estimated optimal size. Okay, this is the estimated size required by the SQL work area to execute the operation completely in memory. Optimal execution, suppose sorting, if it does the sorting completely in memory, then it will be a optimal sorting, and this is very much good for performance. Okay, it might be derived from other either optimizer statistics or from previous executions. Optimal execution means Oracle does it completely in memory. For example, for optimal sorting, Oracle reads and sorts the whole data, keeping everything in memory, and if the memory is big enough to hold the entire set of data, so Oracle does not have to use any space in temp. This is the optimal execution. Okay, and Oracle does not allocate the entire sort area size as it sorts. It only allocates memory as gradually we read the data in Oracle. Okay, and the second option, one mem, this represents estimated one pass size, the estimated size required by the work area to execute the operation in a single pass. Okay, it is derived from either optimizer statistics or previous execution. In one pass, Oracle will start using the disk. You can have like one pass sort, one pass hash. So for example, in one pass sort, Oracle reads some amount of data and sort it, and when the memory fills up, Oracle writes up data to temp, and Oracle does this over and over again, over and over, until it has read the entire set of data and sorted each of the chunk of the data. After it's done, then there will be sorted sets of data on the disk, on the temp, and Oracle have to merge them into single set. Okay, so we are doing a one pass sort if we have enough memory to read a chunk from every single sorted run at at once. Okay, and this is the operation from which the performance starts bit degrading. But even in one pass sort the performance is good, but when you don't have memory to do one pass operations also, then it will go for multi-pass, and which is very much bad for performance. Okay, and another 2 column, used mem, it represents memory used by the work area during the last execution of the cursor, and use temp, amount of space used in temp for last execution. So we'll again do some tally. We'll check from the particular view $SQL work area. Okay, we'll for our particular query we will join $SQL and $SQL work area, and in $SQL work area there are some columns like estimated optimal size. It is same as the omem. Okay, and estimated one pass size same as one mem. Last memory used, this is same as the used mem, and last temp size. This is the last used temp. Okay, so I'll this is the updated query. Fine. And another problem with this, we'll find out this two, it is showing us 220k in use temp. Just keep that in mind, we'll show interesting thing. Okay, okay, let's execute in here. Okay, uh, okay, again, just view this plan. Okay, then I will execute my query here. Okay, so here you can see, okay, the format is not, I need to format. So let's tally with my toad. We can do it here also, same thing. Okay, so if you see OMEM, it is showing us 248M. Now for better viewing, I'm just turning the I'm showing it to uppercase. Okay, so this is the estimated one pass size. It is in bytes. By this I am getting the OMEM, it is 248M. Okay, and estimated one pass size, it is showing it as 5254k. I am getting it from here, and here you can see 5254k. Okay, and used mem, this is the last memory used by 1024 by 1024 use mem. Total last memory used for last execution, it is 84M. This all values here, it is showing fraction, here it is rounded off. Okay, and another thing, there is bit problem with this particular column. 220k it is showing, but in real it is 220am. Last temp size, it is stored the as bytes. Okay, and if you divide by 1024 by 1024, you get 220 MB, but it is showing here 220k. This is one problem with this display cursor output. Anyway, these are pretty much clear now, I hope. Okay, so this is what I wanted to cover in this session. Thank you. I hope you have liked it. Thanks.